Hey everybody, in this video we are going to be building Wordle using React.js. For those of you guys who don't know about Wordle, it is a super popular, super fun word game where you have 6 guesses to guess a 5-letter word. It's tons of fun, it's pretty straightforward, and it's a great opportunity to showcase my favorite React stack and how efficient and effective it is in building front-end applications. So we're going to get into it. I hope you enjoy this video. Okay, so the very first thing I want to do is install globally a package called Create Next App. This is going to help me bootstrap Next.js applications. I've already run this command because I've worked with Next.js applications before, so I'm just going to cancel. But now we can run Create Next App, and I can pick any one of their many examples, which are kind of bootstrap setups. I'm going to pick the one that has Tailwind CSS. This is going to give me Next.js, React installed, TypeScript set up and configured, and I'm also going to have Tailwind set up and configured. So I'm going to be coding in just a few seconds. Okay, boom, that is done. I'm also going to use MobX and MobX React Lite to manage my UI state, my data layer. So I'm going to add those to my project. That's it. My entire project is bootstrapped. Now we can start coding. I'm going to run code dot and yarn dev. This is the project that has been bootstrapped. Push it over to the left. You can see we've got our pages folder, which is what we're going to be working on here. We're just going to need the home page. Wordle is a 1-page application. We've got Tailwind already set up and configured for us. If we want to add some colors, I'm just going to use Tailwind's basic built-in colors for this. And we've got prettier going, and we even have TypeScript. So I'm going to change TypeScript to strict false for this project. If you don't know the difference, you can look up what that is, but that's just going to help me not have to worry about TypeScript stuff because we're focused on building this in React. You can see here, if I go back to my terminal, we've got a local host running on port 3000. So I'm going to open up that URL. Ta-da! And we are good. The first thing I'll need is some data. So I did some Googling on a dictionary of all 5-letter words, and I found this. So I'm going to click on the raw. I'm going to copy it. And then I'm going to bring this over into my project here. I'm just going to go ahead and create a 5-letter words JSON or a words.json. And I'm going to paste it in here, and I'm going to use find replace to replace all /ns, which is the end of a line. If I turn on regex, you can see we're matching the end of every single line. And I'm going to change that to quote, comma, /n. And then I'm also going to replace the beginning of every line, which is in regex, this little caret. I'm going to replace that with a quote. And so ta-da, now we have it all in JSON format. I just have to add brackets to the beginning and brackets to the end. And now we have a gigantic words JSON file. So before I do anything, let's go over to Wordle real quick and see what our components will be. See, we're gonna have a little header that could probably just be a pretty H1. And then we're gonna have 6 boxes of 5 guesses. You can see I already made a guess here. So I did hello. If I did tests, you can see that I have some other ones. These are correct letters, but in the wrong place. This is the correct letter in the right place. That's actually a pretty great guess there. And so now what we're going to need is we're probably going to do a guess component, and I can spit out 6 of those on the page. The guess component will probably receive the word you're actively guessing, whether you have guessed it or not, because obviously as we're typing a word, it doesn't show the yellow and the green. What word we're trying to guess against, so we can know whether to show things as yellow or green. We also have a Qwerty component, like a Qwerty keyboard component that will kind of spit out the letters. Also have access to what we have guessed and what the word is, so we can kind of derive if our guesses cause any of these to turn yellow, green, or dark gray. I guess we'll have another component in here that says you've won, you've lost, start over again. Let's go get our app structured now against this. Okay, these are our 4 components that we will have on our page. We'll have our wrapper div, which gives us a background, centers everything on the page. Our title, our guest component, which does not exist yet. Our Qwerty components, and our one loss. We will also wrap this in observer because we're going to use MobX for a store here. Let me go ahead and create that store. I'm going to return puzzle store, which is just going to be a plain old JavaScript object. Let me go ahead and create that and import that. Let's get these components and this store created. And this is what our homepage component will look like. Okay, there we have it. Let's go ahead and make a little bit of design, and then we'll move into the functionality of the game. Again, I have Tailwind installed, so it's gonna be pretty easy to do. I can just add out some class names right now. I'm gonna make this thing a gray background, make it full width, full screen, and I'm gonna add a flex column layout and center all those flex column children on the page. There's our flex column. Let's make this thing full screen, a width of screen, a height of screen. Let's make the items centered. Flex call, item center, justify center. Man, that takes care of a lot of things. I use item center, justify center all the time. You can also see that I have this plugin on Visual Studio Code called Windy CSS. It kind of collapses your Tailwind class names when you're not using them. I have a love-hate relationship with it. I'm not sure if I love it or hate it, but I think I like it more than I dislike it, so I do tend to leave it installed. Let's go ahead and make this header look at least a little nicer. Text 6XL, font bold, uppercase. One fun little CSS trick you can do is you can actually make the background be the text. If you make the text transparent and the background clip to text. So I'm going to do that. I'm going to make a gradient background over this H1, and then I'm going to make the text transparent and make the background clip text. And to do a gradient in Tailwind, you basically say BG gradient to, and then what you want it to go to. In this case, the bottom right. So BG gradient to BR. There we go. We've got this like gradient background, but instead of filling the div, we're actually background clipping it to the text, and we're making the text transparent so you only see the background. Fun little trick for giving yourself fancy little letters. Let's go ahead over to this guess component. It's going to need to know a few things. It's going to need to know the word we are trying to guess. And then we also need to know the word we are actively typing. We also need to know, have we guessed this word, or is this a word that the user is currently typing? Let's say false. Okay, let's go ahead and build out this component. Now what we want this to do, let's make a CSS grid layout that spits out 5 letters every single time, no matter how long our guess is. So I'm going to make this a CSS grid. There we go. I've made it a grid. There's nothing inside of it yet. I want to spit out 5 boxes. So to do that, I can create an empty array that's 5 things long and then map that. And the return of each map function will be a component. There we go. You can see that I have now returned 5 divs that each have a T in them. I filled it with 0. I don't care what I filled it with. You just have to fill it with something. If you don't fill an array with anything, then it kind of doesn't iterate. It's not an iterable, even though you made an array that is 5 long. So you have to fill it with something. You can just call fill there, but TypeScript is going to bark at you. Fill it with something. And now I can map this out to the guess letter, which is going to be guess.I. And there we go. Now GUESS is my guess, because that's what I'm passing in here, GUESS. Nice. Let's just add a little bit of style to these, and we're getting pretty close. Ooh, that's a little bit big. Let's make this height maybe more something like 16. Nice, feel a little bit better. That gray is a little too strong. Let's knock it to 400, and let's come over here and make this gap 2. Nice, okay, that's feeling pretty good. We've got our letters in there. Of course, now our text can't be seen. We need to make our text white. Let's also make it uppercase. Let's also make each one of these boxes display flex, so we can do items center, justify center, and we can make sure that each letter is centered on that box. Again, items center, justify center. Wow, I use that all the time. So if we were to spit out 6 of these, then we would basically have Wordle. Let's see what that looks like. I need to add a little bit of a margin bottom over there to my guess component. Let's do that, maybe an MB of 2 to match that gap. Boom, looking nice. Instead of copy, though, I'm gonna want to actually do that same kind of trick where I do an array of 6 and each one spits out a guess. So let's do that. Boom. So we have spit out 6 guess components. Each one of these is going to get a word at some point, a unique word, but the guess component is kind of done. I guess all we need to do at this point is we need to compare the letters to the word to show you which letter was correct. Because if you remember on Wordle, we're going to show you if this correct. Is this correct? Is it loosely correct? So let's come back over here to the guess component. So inside of each letter box, we're going to do a check to see if we're an exact match, an inexact match. If it has already been guessed, we will do this. If it's not been guessed, we're not going to do anything. So let's go ahead and take care of that here real quick. Okay, I have that. So let's see. If we have not guessed it, our background color will be black. Otherwise, we're going to move on. So we're going to say if the guess in this place is the exact same as the word in this place, right? So if G, which is index 0, is the same as index 0 in the word we're guessing, then we're going to go background green. Otherwise, if the word includes our letter at all, then we're going to go background of yellow. Otherwise, we're going to stick to that background of black. So the only thing we need to do now is we need to put that actual background color in here. So I'm going to turn this into a variable that I pass in, kind of a string, and then I'm going to add BG color. And I already have BG black hard-coded in here, so let's get rid of that. And now I'm expecting that I should see something. Right, I said it was not guessed. Let's say it is guessed. True. Now it's working. This was TUESS, then it would say that that is green. Nice. And if I do the whole thing, nice, looking good. Okay, this component is done. We can call this thing done. At this point, let's go and build the logic for our game. Okay, so our puzzle store has no data values to it now, but this is about to change. We can say that we're guessing a word. The word is currently blank, and we can say we have guesses. Currently, we have no guesses. We also need to know which guess we're currently typing on. By default, that's going to be 0, index number 0. And that's actually all the data we need. If we know the word we're guessing, and we know the guesses we have made, and we know what current guess we're on, so if we're on guess 2, let's say this right here is an array of 3 words, and we know that our current guess is 2, then we know that these have already been guessed, 0 and 1, and we know that 2 is not been guessed yet, right? The user has typed TES or TESTS, but they have not actually guessed it yet. From this information here, just what we're guessing, what guess we're on, and the guesses array, we can determine if they've won, if they've lost. So all we need to do now is add what are computed values based on this set of information, this very tiny set of information, and we can go ahead and build out our game. So let's add some of those computed values now. You can see that we now have these computed values. We can figure out if they've won or if they've lost based on those comparisons. Let's make an init function that can kick off this game by guessing a random word out of our JSON we put together, and we can start off a game. Okay, so whenever you init the game, whenever you kick off a new puzzle, it's going to select a random word from our words array. It is going to replace all the guesses with empty strings, and it is going to say the current guess is 0. So let me go ahead, get rid of these. We don't need these little example samples anymore. I can now kick off a game when I start off on use effect. Use effect with an empty array is going to run this function right here once and only once, and that's when the component mounts. So I'm going to say store.init. Gonna go ahead, save, and now let's print out store.word. Just kind of see, nice, tiara. Man, I would not have guessed that. So now every time I refresh my page, it's giving me a new word. Excellent, that is working. Let's also print out our guesses just so we can kind of see. But we've got our word and we've got our guesses, so we can kind of debug this as we go. Awesome, let's go ahead and connect our guesses now to these actual guess components and our word. Let's kind of wire these up. Our guess component is now wired into our store. It's spitting out all the words. And now what we need to do is we actually need to make a key press listener for the entire page. And when you hit any key on your keyboard at any point in time, no matter what you're focused on, it's going to start spitting out the words into what your current guess is. So let's go ahead and add a handler here. When we render our component for the first time, when it mounts, we are going to listen to all keyup events, handle them with a store handle keyup function, which I've not created yet. And then when our component unmounts, we're going to do this cleanup function, which is what we return, and we are going to remove that listener. Let's go back over to our store and add that handle keyup function. If you've hit the enter key, we are going to submit the guess and go no farther. Submit the guess is, hey, if the word you're trying to guess is a legitimate word, then we're gonna say, awesome, bump up to the next guess. That's all we have to do because you've already typed it in. The guess you're working on already has all the letters in it. We just need to say, hey, we're gonna start working on the next guess now. And of course, if that gets up to 6, you've lost. So that's all we have to do on submit guess is say, hey, we're gonna work on the next guess now. If you hit backspace, we're going to get the current guess you're using, which is this guess's index current guess. And we're going to say that equals the current value, but we're going to slice off the last character. So we're going to take the current value, slice it starting at 0 and go all the way to the length -1. So we're going to return a slice of your current guess if you hit backspace, and then we're going to return. And otherwise, if your length is less than 5, right? So you've typed in 1, 2, 3, or 4 characters, but not 5. And if it's the letter A through Z, uppercase to lowercase, then we are going to append it in lowercase form to your word. That lowercase is very important because obviously we're going to be guessing all lowercase words because that's what's in our JSON. Okay, so now if I type this and if I refresh, I should, oh great, we got an error. Cannot read property 0 of undefined. This is happening because back here on the index page, I always spit out guesses even when they do not exist, even when we have not initialized yet. So what I actually want to do is I actually want to iterate over store.guesses. There we go. Yep. So I'm going to iterate over store.guesses. Let's type some characters. Nice. Excellent. And I hit enter and you can see I matched an E. We are guessing the word honey. Okay. So I'm going to guess H-O, homie. Nice. You can see that it's working. Excellent. And if I go honey, okay, now I have technically won. Now my keys do not work anymore. So if I add a 1 loss, I can actually make this 1 loss do something a little smarter. It restarted here. Let's see, I'm guessing wilds. Let's guess wilds. And it says you won. Sweet, feeling good. Let's type wilds, wilds, wilds. Let's try to lose here. You lost. Excellent, we're doing good. I can get rid of this 1 loss that we don't need. Actually, I'm gonna make this a button, so store won or store lost. And let's spit out a button here that says play again. So now if I guess correctly, let me go dimes. You can see I'm guessing the word dimes. Hit enter, D-I-M-E-S. Nice, can I play again? Does this work? Woohoo, it works. So now I have a complete game. All I need to do is make these buttons prettier, and I just need to build out my Qwerty component. So let's go ahead and build out that Qwerty component now. It's gonna need to know what have we guessed, what have we guessed exactly, and what have we guessed inexactly? Like what is a T that's over here? Oh no, and I'm noticing this thing right here. It is saying meta. Notice when I hit Control or Shift, it's actually spitting out S-H-I-F-T. That's not good. That's because in my puzzle store, I'm matching A to Z, and the word META does indeed match that. So I need to go, if it starts, A-Z, and then ends. Now let's see if it works. Haha, now ASDF works. The meta key does not happen. The shift key does not happen. Whew, that could have been a weird little quirk. So now let's go back over here and let's go ahead and add the store in here. And we can build out this Qwerty component. We're going to want to map 3 arrays out. That's going to be super easy to do. There we have it. We have created an array, which is very easy. I just moved my finger across the keyboard, row number 1, row number 2, row number 3, and then I'm mapping over that array. So for that row, we're going to split that string into a bunch of characters and then spit out a div for each key. Now let's just add a little layout sauce here. Each row will be a display flex, and then each item inside that row will be a small little box with rounded corners. So you can see that on our row, each row has flex with justify center. Each item inside the row has a tiny little margin around it. It is itself got a display of flex, 10 wide, 10 high. We did that classic item center, justified center. Give it a little bit of border radius, a background of gray, and we've uppercased it. All we need to do now is create some helper functions on our store to let us know if each character has been guessed or not. We need to know if this key, this Q key right here, has been guessed, if it's a part of the inexact matches, or if it's part of the exact matches. So let's go add those helper functions to the store. Here are the 3 helper methods that I have put together. I've added a computed function called all guesses. That's pretty easy. That's just going to take the guesses so far, except for the one we're working on. So all the guesses up to this point, but not the one I'm working on now. Let's join them together into one big string. Then let's split that string into an array of the individual letters that make it up. We'll get some duplicates in here. So if you guess a T in one word and a T in another word, there will be multiple T's in this array, but it's going to work because we can do does this array include the letter Q? And if it's anywhere in there, it's going to work. The exact guesses was the most complicated one. We basically took the word we are trying to guess. So in this case, we're trying to guess the word goody. And then we started stepping through each letter in that. And we're going to filter out the ones that have no matches. So if we're on character 0, then let's return character 0 for each word we have guessed. And if that array includes our letter G, there's an exact guess for G. It's a little bit tricky, but that was basically the easiest way to put that together. Inexact guesses ended up being much simpler. We could take the word that we are trying to guess, which is goody, and we can split it into all the individual characters. And let's come back with an array of the ones that we have guessed that match. So let's go through each letter in Goody and see if all of our guesses, which we already came up with here, if all of our guesses includes that letter. That was pretty easy. So if O has been guessed by any word before, then O will be in this array. So this is going to be an array of the letters we have guessed. This is going to be an array of the letters we have guessed exactly. And this is going to be an array of all the letters. Now we can go back over to our guess Qwerty keyboard and come up with some basic logic that will figure out what our background color should be. So you can see what we have done is we've said, hey, we've passed the store in as a param. And if store.exact guesses includes our key, background color is going to be green 400. If our inexact guesses includes the key, which I shouldn't say key here, I'll say char. If our inexact guesses includes it, then we're going to do yellow. If all guesses includes it, we're going to darken it a little bit. Otherwise, we're just going to leave it as it is. Let's refresh it and test. Our word is jumbo. I hit enter and I don't see anything. I am not wrapping this in observer, which means it's not going to observe changes to the MobX store. That's very important. This is the one penalty you pay with MobX is you have to wrap any functions that are getting a store as a param, not values on the store, but the observable, you have to wrap those in observer. It also isn't working because I'm not passing this background color in. I'm defining this background color, but I'm not passing it in anywhere here. Let's turn this to a variable. BG color, and let's get rid of BG color here. Let's go racks. You can see I got yellow, 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 gray, gray. Boom, we have built Wordle, people. It looks like it is done. I don't like this, feels a little too bright to me. You could do some adjustments, but at the end of the day, we have just created Wordle start to finish in just a few minutes. So there you go. In just a few minutes, we've essentially created all of Wordle. Yes, there are a few finishing touches we could add to it. We could add card flip animations to the letters when you guess a word. We could also make the Qwerty characters buttons so you could use a mobile device to operate it. But we've basically built Wordle in just a few minutes because we picked the right stack that lets us go really fast, and we still have a reliable, non-hacky app at the end of the day. So this is what you want to do when you're making your tech decisions. What helps me go fast and reliable as much as possible? If you enjoyed this video, make sure you like it, make sure you subscribe. We'll catch you around on the next video.